Welcome to this video in our series, A Beginner's Guide to the C Programming Language. In our last video, we discussed strings in C. We learned about different string functions and how to process strings using custom code. In this video, we will discuss files. Applications store data in external memory. This data is stored in files and can be reused every time the application executes. We will discuss the different types of files in C and use library functions to perform different operations on them. Please like and share this video, follow our channel, and subscribe for notifications on new videos. A file stores data in external memory. Different kinds of data is stored within files. An image editor would store its data in JPG, BMP, and TIFF image files. A sound recorder will store its recordings in an MP3 format. A word processor would store documents, and a relational database would store data in the form of tables. Each of these different types of files have a structure that may be a proprietary or a known format. A C program can perform operations on files using library functions. These operations are performed by the operating system. The C library functions make system calls to these functions within the operating system in order to perform different operations. We will learn about the types of files in C and the different library functions that give us access to a file, read and write data into it. Firstly, there are two kinds of files in C, a text file and a binary file. Typically, in a text file, you would store text information. In these files, all texts that end with a carriage return and line feed characters are converted into a single line feed on output, and all line feeds are converted to a carriage return plus line feed character on input. Also, the end of file is marked with an EOF character. A binary file is used to store information in binary, typically a combination of text and numeric values in a binary format. A binary file does not perform any line feed translations as described in a text file. Secondly, there are different kinds of file operation functions available in the C library. We will discuss the stream I/O functions. A stream is an abstraction of an I/O channel which can be a source or destination of data. In a C program, the startup routine automatically opens a few streams for us. These streams are the standard input, standard output, and standard error streams. When the program closes, these streams are closed as well. The function printf is an example of an output function that writes to the standard output stream. When we want to use a stream, we first need to open the stream. Then we can perform I/O operations on them. And finally, when we are done using the stream, we must close the stream. As mentioned earlier, three streams are opened at the beginning of the program and closed after program execution. Different I/O functions in the standard library perform read and write operations on these streams. Any additional stream that we use must be specifically opened by the programmer before any I/O operation is performed on them. After all operations are performed, then these streams need to be closed before exiting the program. As mentioned earlier, we can perform various operations on a file stream using library functions. Let us discuss each one of them now. The first function is the fopen function. The syntax of the fopen function is shown here. The function returns a pointer to a file structure which is declared in the stdio.h header file. The internals of the structure are irrelevant and must not be used by you when processing the file stream. The file structure should be treated as an opaque reference to a file. The file pointer returned by the fopen function is used in all functions that perform operations on the file. You should not access the members of the file structure in your program. If the function fopen cannot open the file successfully, it will return a null or a zero value. The fopen function takes two arguments. The first argument is the full name of the file. The file name should include the drive specifier, the full path name, the file name, and the file's extension. If any of these are not provided, then the default drive, the current path, and no extension is assumed. The second argument to fopen is the open mode. The open mode consists of the following options. R opens an existing file for reading. W opens a file for writing. If the file does not exist, a new file is created, else the existing file is truncated. The open mode A opens a file in the append mode. All writes will take place at the end of the file. If the file does not exist, a new file is created, else it remains unchanged. That is, the existing file is not truncated. The R plus mode opens a file in the read-write mode. The file position is set to the beginning of the file. In the W plus mode, the file is opened for both read and write, but the file is created if it does not exist and truncated if it is. The A plus mode opens the file for both reading and appending. The file is created if it does not exist and remains unchanged if it is not. All write operations take place at the end of the file. In addition to the above, the open mode contains the characters B and T. The character B specifies that the stream is a binary stream. T specifies that it is a text stream. Once a file is opened, you can perform read, write, and other operations on the file. After you have finished working with the file, you need to close it. The function fclose closes the file and frees all the system resources that were attached to the file. The function takes one parameter, that is the file pointer value, that was returned by fopen. Once a file is closed, you can no longer perform any read or write operations on that file. The example shown here uses the fopen function to open a file called mydata.txt as a text file. This file is opened in the read mode. Note the full path name provided in the call to fopen. And also note the double backslashes, which is the escape sequence for a single backslash. The file is opened as a text file in the read mode. If the file is present in the path specified, then the file pointer fp will contain a non-zero value. In this code segment, all we are doing is closing the file and exiting. If the file pointer fp is null, then the file was not opened successfully and we exit the program without performing any further operations on the file. An important concept to understand when working with files is the current position pointer. This is the position in the file where the next read or write operation will be performed. When a file is opened, the current position is set to the start of the file. Every time a byte is read from the file, the current position value is incremented by 1 after the read. If you read a block of 10 bytes, then 10 bytes of data is read starting from the current position, and at the end of the operation, the current position value is incremented by 10. The C library contains functions that will allow you to read or move the current position pointer, enabling random reads and writes on the file stream. The next library function we discuss is the fgets function. You are familiar with the getters function that we learned about in the previous video on strings. The fgetters function is similar to a getters function, only that getters gets input from the standard input stream, whereas fgetters gets its input from the file stream that is passed to it as an argument. The function fgetters takes three parameters. The first argument is the pointer to the string that will hold the data read from the file. The second argument is the max number of characters to read from the stream. And the third argument is the file pointer of the file stream. fgetters function reads characters from the stream till it encounters a line feed or has read the number of characters specified in the argument. Then it null terminates the string and returns. You should use the fgetters function only on text files. The next function we need is the feof function. It checks if the file stream has reached its end. If it has, then it returns a logical true value, otherwise it returns false. The example shown here opens a text file in the read mode. If the file is not opened successfully, that is, the file pointer returned is null, it will exit the program. Otherwise, we will read one line of the text file and display the line on the screen. This continues until we reach the end of the file. If the function feof is true, then it breaks out from the loop and exits. The file is then closed and the program terminates. Just like you have the fgets function, you have many functions that are similar to the input-output functions we have learned in the stdio library, like printf, scanf, getC, putC, etc. The file stream versions of these functions are fprintf, fscanf, fgetf, fgetc, and fputc. Let us look at each of these functions. The function fgetc takes one argument, that is the file pointer of the file stream. It reads a single character from the stream at the current position pointer, increments the current position pointer, and returns the ASCII value of the character read. The function fputc takes two arguments. The first argument is the character to be written into the stream. The second argument is the file pointer. The character is written at the current position of the stream. Note that for write operations to be successful, the file must be opened in the write, append, or read-write modes. If not, the operation will fail. The functions fprintf, fscanf behave exactly like printf and scanf, only instead of inputting from the standard input or outputting to the standard output, they perform their operations on the file stream. The functions take variable arguments. The first argument is the file stream pointer returned after a call to fopen, and then you have the format string followed by the argument list. The data is written or read from the stream. In case of fscanf, the call is made by passing the address of the variables to store the data into. After fscanf is done, these variables will contain the data that is read from the stream. All the input-output functions we have covered so far are functions that you would use on text files. If you want to read or write binary blocks of data, you can use the fread or fwrite functions. The fwrite function takes four parameters. The first argument is the starting address of a buffer that contains the data to be written. The second argument is the size of the memory blocks to write. The third argument is the count of the blocks to write. And the final argument is the file pointer of the stream on which this data has to be written. Similarly, the fread function is used to read a block of binary data from the stream into a memory buffer. The arguments are similar to the fwrite function. Let's look at a simple example that will perform a block write into a stream. We have declared and initialized an int array of 5 elements. The file stream is opened in the write mode as a binary file. Then the fwrite function writes a block of 5 integers into the stream. You can see the arguments passed to the fwrite function. After the fwrite function, a total block of 20 bytes of memory is written into the file. Note the typecast of the starting address of the buffer to a void pointer. Then the file stream is closed. Then let's discuss the last two functions that are related to manipulating the current position pointer in the file. The function fseek relocates the current file position pointer to any desired location within the file. It takes three arguments. The first argument is the file pointer of the stream. The second argument is the offset value. And the third argument is the position from which the offset will be determined. The symbolic constants defined for the third argument are seek set to offset from the start of the file, seek end to offset from the end of the file, and seek current to offset from the current position of the file position pointer. For seek current values, the offset value can be negative or positive. The function ftell will return the current value of the position pointer in the file stream specified as an argument to the function. The example shown here calculates the size of the file. It opens a file, then repositions the current position pointer to the end of the file. Then it calls the function ftell to read the current value of the position pointer. This value of the current position pointer is the size of the file in bytes. Let's look at an example using files in practice. The program declares a book record structure called books. An array book list of books is created and initialized. This array of books is written into a data file called booktable.dat using the fwrite function. So now booktable.dat contains multiple records of fixed lengths that contain information about books. We have opened the file in a read-write mode. So besides writing, we can also read from the file. Then we input a record number from the keyboard or -1 to exit. The record number is then used to find the position of the record which needs to be read. The function fseek is called to reposition the current position pointer to the start of the record. Then the fread function will read the record from the file into memory. The corresponding record is then displayed. Let's try it with a couple of records. Finally, we will enter -1 to exit the loop and the program terminates. We have reached the end of this session. We covered some file input-output functions in the standard C library. We have completed the second part of our course where we've covered derived data types in C like arrays, strings, and pointers, and program structures like branches, loops, and loop control statements. We also learned about a few library functions in stdio and string libraries. In the final part of our course, we will discuss dynamic memory allocation, data structures, and implement a linked list. Please follow our channel, like and share this video, and click on the bell icon to receive notifications. In the next video, we will cover dynamic memory allocation. See you then.